Okay, welcome to my YouTube channel. And today's video we're going to look at graphs of distance, acceleration and velocity. Okay, so we start for the first time. The first graph is the distance time graph. A distance time graph is a graph where distance is plotted against time. That's simply a graph where distance is plotted against time. The diagrams below represent the distance time graph for a motion of object. So here you need to know, just by looking at the graph here, you need to tell what is going on, what's the motion of this object. When each time you see this, the object is going like this in a distance time graph, just know that the car is accelerating. Why? Because clearly here it doesn't show any curve at the end, like as if it's going to go down again. Just show as continuous increasing. There is showing that the object is accelerating. Hope it's clear there. Then each time you see a graph, the key thing here, you need to note where the graph is starting from. After you note where the graph is starting from, you need to note where the graph is ending. How is it ending there? Is it forming a curve? Whether you like it or not, if you continue this graph, it will form It will form a curve, showing that the object is decelerating, and eventually it will reach zero again. Just like that. It will never reach zero because distance will never be zero. It will never be zero. So it will form a horizontal line there. That's how you're able to tell, okay, this object is accelerating, this object is decelerating under distance time graph. We move on to the next graph. This is this one. Each time you see a horizontal line on the graph of distance time graph, just know that it means what? It means that the object stopped moving. It was at rest. When the object is at rest, this line will be what? Will be displaced. Continue moving. The next point is that the horizontal straight line indicates zero speed, which means here the object has zero speed. It is resting. So okay, let's look at this one. Here, each time you see a graph which is looking like this, it simply means that the object was moving with a constant velocity. It traveled a distance of 10 meters in 6 seconds. Not exactly, these figures are always being given. Here was a mistake. I was supposed to give figures here. Meter is supposed to be 10 here, then time is supposed to be 60 here. That's how we are supposed to get these units. Unfortunately, there was an error on making this graph, but the key concept here you need to learn is that each time you see a straight line, just know that the object was moving with constant velocity. Then if you want, you can even find the velocity, which is using this formula here, which is velocity is equal to distance over time. Okay, let's look at some examples here. Example number 1 simply states that it goes like this. An object traveling a distance of 40 meters in 4 seconds. Number 1A, sketch a distance time graph to interpret the information above. Calculate the velocity of an object. So using that formula, from looking at it, you can able to find out your velocity and just plot the object by using the y-axis as your distance and your x-axis as your time. So starting from 0, of course, let me show you the graph. The graph should look like this one. Here, I said on the y-axis it's supposed to have what? Distance. Then on the x-axis it's supposed to have what? Time. Then here just start from 0, then 1, 2, 3, 4. It can go on and on even to infinity. Same applies here. But in the question we are given specific distance and how long it took to reach that specific distance. Hence, if you want to draw that information on the graph, we should follow those information or data given in the question, which is what was 40. It reached 40 meters, but it took how long? 4 seconds. That's how you interpret this type of graph. Then finding the velocity, simply use the same formula. Velocity is equal to distance over time. So here, after punching in, after substituting in the formula, you say that, okay, velocity is equal to s over t, and we know that our total distance that traveled by the object was what? Was 40 meters. And the time it took that object to reach 40 meters, it was 4 seconds. Then just do the calculations here. You find the velocity is 10 meters per second. Now here's an exercise for you. You can do a quick exercise. I'll pause the video for just a few seconds and leave your answer in the comment section. Okay, then we move on to velocity time graph. It's one and the same thing, but not completely one and the same thing. They are similar. So for us to define what, let's define velocity time graph. This is simply, velocity time graph is a graph where velocity is plotted against time. The diagrams below show the velocity time graph for motion of an object. Okay, let's look at this. So here, each time you see such on your, you need to identify. In the exam, I want to tell you that you are dealing with a velocity time graph or distance time graph or acceleration time graph. It's up to you as a pupil to identify which type of graph you are dealing with. And that, in order for you to identify which graph you're dealing with, you need to pay attention to the y-axis and the x-axis here. So here on the y-axis you have velocity, and on the x you have time. So what changes is what? Always the y-axis. The y-axis will tell you what type of graph you're dealing with. So here we're dealing with a velocity time graph. So when you see such kind of motion here, what does it mean? When an object starts from 0, it moves on with a uniform line, then it drops to 2. Simply means that the object was moving from rest with constant acceleration to a velocity of 12 meters in 2 seconds. So each time you see a uniform line in a velocity time graph, just know that the object is moving with what? Constant acceleration. Then the slope indicates constant acceleration. This is the slope, the line in other words. So constant or uniform acceleration. That's what it means. Okay, let's look at another example of the graph and our velocity time graph. So each time you see such a graph, what does it mean? When you have a line, a slope, drawing straight, going uniformly, and the horizontal here, the graph is horizontal, then it drops. So here, what we're trying to say that velocity was increasing uniformly, and acceleration was what? Constant. When the line is horizontal, simply means that the velocity of the object was moving with what? Constant what? Velocity for how long? For 2 seconds. How did I get 2 seconds? By finding the difference between 2 and 4, which is 2. So let's look at this other graph here. Okay, so you have this graph. So here, we're not interested how the object started moving. We're interested when the object reached what? 12 meters per second. That's why here you have no line coming from what? 0. Instead, it's coming from what? 12 here. So we're just interested in when the object was moving with what? 12 meters per second velocity. So now, Here the object moved with 12 meters per second, or moved with a constant velocity for how long? Since it's 0 up to 3 seconds. So here, to describe this motion from here to here, simply say, okay, the object was moving with constant velocity for how long? For 3 seconds. After 3 seconds, you'll notice here the line bends down. This simply means that the object started to decelerate. So for you to find out how long it took the car to decelerate, just go where the line is bending there, the time is 3, and where the line touches comes to rest is is at 6. Let's find the difference between 3 seconds and 6 seconds. That is that's how long it took that object to decelerate. So here technically it took the object 3 seconds. I hope it's clear on how I'm describing this graph, because it's very important that they'll always come in the exam, especially pure physics paper 2, section B, sometimes even section A. They normally come. So okay, when you have such type of graph, what do they mean? What are they trying to imply? Simply, the object was moving from rest with constant uniform acceleration to a velocity of 12 meters per second in 2 seconds. And then it moved with the constant velocity of 12 meters per second in 2 seconds, and finally decelerated uniformly to rest in 2 seconds. So in summary, each time you see a graph which is forming a curve, and the velocity time graph is forming a curve, just know that there's no uniform acceleration. And each time you see a graph going like this upwards, just know that the object is moving in non-uniform deceleration or retardation. Hope it's clear there on the summary. Now let's look at when it's horizontal. So when the horizontal here simply means constant velocity. The object was moving with constant velocity. When you have such, simply means the object it had a negative velocity, shows that the object was dropping or falling. What's that it mean? It means when you have negative velocity, simply means the object was dropping. It wasn't moving in a horizontal manner. Instead, it was dropped from a certain height. When you see such kind of graph. So you need to note another thing, that the slope or gradient on the velocity time graph represents acceleration. Here, when I say the slope, we're just simply talking about this one here. From here to here, that's talking about what? Acceleration. So if you find the gradient of this line, you actually find what? The acceleration from here to here. Then you can do the same from here to here. You can find that retardation. Hope it's clear there. We move on. So here, you need to note another thing. Each time, for example, let me use this graph. Okay. Let me show you this statement here. Then I use that graph. So you need to note that the area under velocity time graph represents distance covered. So for you to understand this statement, simply I have to go back to here, then I do this, and you say this, okay. You notice after plotting velocity against time, the motion of that object will form certain shape on that Cartesian plane, on this graph. It will form a shape. In this case, our example, what kind of shape has this motion formed? On the positive part, not the negative part, but the positive part. You will notice that from 0 up to the top here, that's formed a triangle. It has this shape, following like this square, that's formed a triangle. And yet they are telling us that if you have such a shape and you you have values and you're able to find the area of this shape. For example, if you want to find the area of a triangle, of a right angle triangle, what do? You just simply say area is equal to half BH. So when you find the area of this triangle, you actually find out how the distance this object traveled within this specific period of time. That's how we find distance. Just simply find the area of the object formed. You have different shapes. Even a rectangle can be formed. Even trapezium can be formed. So you need to know the formulas for each and every shape here. For example, we have a diagram below shows the speed versus time. The speed, velocity, time graph versus time graph of an arrow which was shot vertically upwards. Okay, here you may ask yourself, why did it start from 100 meters per second rather than starting from 0? Why? Because it was short. You know, when you shoot an arrow, it doesn't start from rest. It goes with what? The speed. Up is clear here. The solution question. Okay, what's the question? At what speed was the arrow shot at? Of course, it was what? 100 meters per second, because that's where the motion started from. Then the next question reads, how long did it take the arrow to reach its highest point? So here it took 10 seconds. Why 10 seconds? Because when it was shot, it started from 80, it never touched, it never stopped. It just went. The line dropped at what? At 10. That's how you find the highest point. If the arrow dropped at 4, could have meant that it took 4 seconds, like it dropped at 10. So determine how high the arrow rose. So here, let's simply use the equation of linear motions to find how high. So linear motion equations, please, they are very important. You have to know them whether you like it or not. Mechanics always come in the exam. Those things, you have to know them by heart. Okay, example number 2. This is example number 2. So the same thing applies. But I won't look at it due to time. So I've exercise. You can attempt these questions. Where you have challenges, you can leave a comment. Your comment in the comment section, then I'll be able to respond to you. Okay, let's look at acceleration. Acceleration time graphs. Acceleration time graph is a graph where acceleration is plotted against time. The diagrams below represent acceleration time graph. So each time you see this kind of graph here, which is on your screen right now, it simply means that constant deceleration. Here, the line at the bottom here, I will decrease in what? Let me just show you. Okay. So here, be careful. You have this line here, and also have this line here, down here. So when you see such kind of graph, the first thing should come in your mind is what? That constant deceleration. The object is what? Decelerating. And again, velocity is what? Decreasing. What happened if the opposite were to happen? So it simply means that constant acceleration and velocity will be what? Increasing. That's simply the opposite of this. The line was on the bottom, now the line is on top. Simple as that. So examples, this example here. As it went past an observer standing by the roadside, a bus decelerated at 1.25 meters per second squared. 30 seconds later, the bus stopped. How far from the observer has the bus moved when it stopped? What was the speed of the bus as it went past the observer? Same thing applies linear motion equations. Just collect the data. After collecting the data, you simply choose one of the equation of what? Linear motion. The exercise, you can attempt this question. Okay, so in our next video, we're going to look at acceleration to gravity. In other words, free fall. Thank you for watching my YouTube channel. Don't forget to like and subscribe and share as well.